Okay class, today we are going to do a little bit of experimenting with conductors and insulators. So if you took your notes and watched the notes video, you'll know that conductors are things that allow electricity to flow, and insulators are things that do not allow electricity to flow easily. So we are going to look at all of these different things, and we are going to test them to see whether or not they are conductors or insulators. So I have one tester I'm going to use here in a little bit on this side, and this is the first tester I'm going to use. So if you have materials and you want to work along with me, you can pause the video, you can collect some of these same items, and then come back and play the video, and you can work right along with me. So you'll need to set up this system here, or this circuit here. It is an open circuit. You can see that there's a space here. I don't have my batteries in yet, so I'm going to want to get those in. It's always good to take your batteries out of the terminals when you're not using the when you're not doing experiments. So, okay, get both my batteries in there, and I'm connected here to my light bulb terminal, connected here and here, so my light bulb should light, and it does. Alright, so when I close the circuit, it lights. So now we're going to have this open circuit here, and we are going to test some different materials. So we're going to touch these two ends to some of these different materials and decide whether or not they are conductors or insulators. Okay? If they are conductors, then we will lay them on the right side. If they are insulators, then we're going to lay them on the left side. So the first one that I will try is the quarter. All right, let's take a look there. Just an average quarter. Nothing special about it. And it is a conductor. Okay, it is definitely a conductor. The light bulb, come on. So we'll lay that on our conductor side. Let's choose another item. How about this blue wooden block? All right, it's painted blue. I'm going to put this one on this side, this one on this side, and you can see my light bulb is not lit, so that means that this blue painted block is an insulator. It does not allow electricity to flow easily. So I'm going to lay it on the left-hand insulator side. Do you think that that could have been just because it had paint on it? Well, let's test that theory. Here's a plain wooden block with no paint on it at all. Was it the paint that made the wood an insulator? No, it was not. It was not the paint that made it an insulator. Our light bulb here is still not lit. So wood is an insulator. Okay. Our next thing that we will be testing is a piece of styrofoam. All right, just a nice little piece of styrofoam there. And I can even poke these into one side and touch it onto the other side. And our light bulb here is definitely not lit. Okay, so this is also an insulator. Yes. So we have one conductor so far, and we have 3 insulators. Let's see if we can't find another conductor. How about our spoon? Okay, fancy little spoon, says it's from Ethiopia. Okay, you can maybe see that there. I think I must have got this spoon from my late Aunt Eugenia. So we will see if this one is a conductor. And it is. Our light bulb lights up nice and bright there, so our spoon is a conductor. So we can add this one to our conductor side. All right, let's look at this one. Okay, nice big nail, sort of flat end there. I'm not sure what it was used for. Found this in my husband's garage. Let's take a look at it. I'm going to put one here and one here. Well, this seems strange. In our notes, it said that metal was a good conductor. But this is not lighting our light bulb. I wonder why that... Oh, what's happening? I think there may be a problem with the fact that this end here is rusted. When I scraped it a little bit, it seemed to begin to flash the light bulb. If I could find a shiny spot on this rusted end, maybe right on the very tip there, I can find a shiny spot. Let's see. There we go. It's definitely a conductor. If I put them both up here on the shiny part, no trouble at all. Lights right up. So we can see that metal is a good conductor as long as it's not rusted or covered with a bunch of dirt. It seems to be a good conductor. So we're going to put that on our conductor side. Let's look at another thing we have here. How about a common eraser? Just an eraser I got out of my kid's pencil box. Let's see if it is a conductor or an insulator. Do you want to take a guess before we start? Okay. It is an insulator. Our light bulb is not lit, so that does not allow electricity to flow easily. So we will put it over here with our styrofoam and our wood. The next thing we have is a little nail. Will this one work like the big nail? Let's see if I can get it on there. Yes, it does. No problem getting our light bulb to light. So this one is a conductor. It allows electricity to flow easily. How about tin foil? It's real thin, simple little tin foil. I mean, these other things were pretty thick. This was pretty, a quarter. In comparison, this is much thicker than a spoon. Has a little bit of thickness to it. Will this thin little papery piece of tin foil conduct electricity? Let's see. I'm going to put one on this end. It does. It most certainly does very easily. Foil is a kind of metal, so tin is a kind of metal, so it is a conductor. Alright. Foil is often used in a lot of kids' science experiments where they build things that they want to close conductors because it's easy to cover something with foil and have it fall onto another metal thing and close a circuit. So yes, foil needs to go on our right side here on our conductor side. All right, how about our marker? Let's try a marker. Nope, our marker is covered in plastic, and plastic is an insulator. All right, I'm going to do this nice little black brass nail next. Okay, it kind of almost looks like a screw, but it's a pointed end, but it's brass, made of brass. Let's give it a try. Oh, it lights up right away, no problem there. Our brass nail here is a good conductor, so we will put it on our conductor side. This is a special kind of tape. Okay, do you happen to know what kind of tape that is? It's black, it's kind of stretchy. And if you look real careful, you might even be able to see the words inside there that say it is electrical tape. So, would electrical tape be a conductor or an insulator? Is electrical tape the kind of tape that you use in order to conduct electricity, or is it the kind of tape you use to stop electricity? let's take a look and see. So we'll put one on this side and one on this side. It is an insulator. Yes, electrical tape is so that electricity, it's sort of rubbery and plasticky, and it keeps it from going places you don't want it to. So it is an insulator. Usually you tape things up so that no other metal can touch it. All right, so we have a couple more coins here. We have, this is a magnet, and we have a screwdriver and a rubber band. Let's try the rubber band next. Nope. Even if I stretch it, it doesn't seem to conduct electricity. Nope, not a conductor. Our rubber band is an insulator. Let's try our magnet. This one you may not be sure of, but we'll have to give it a try. Take a guess before we actually do this. What do you think it's going to be, an insulator or a conductor? Let's put this on this end. It is an insulator. Our magnet does not allow electricity to pass through it, not even if we rub them. What if we put both of them on the one end? No. What if we put them both on the other end? No. What if we swap them, put this one on this end and this one on this end? Nope. Still not a conductor. So we will put magnet over here beside insulator. All right, copper penny. Yes or no? If you said yes, you would be right. All right, now I have this really, really old coin. Okay, it is a 1 cent coin. It is actually from 1888. I think that's right. So take a look, it's really old. Okay, really old coin. Let's take a look here. Oh, it does. It's kind of flashing on and off. As I move it around, it comes on and then it... Why would this be having trouble? Why would this be having trouble conducting electricity? If you said because it is very dirty, you are correct. The dirt is getting in the way and not allowing the electricity to flow easily. It is kind of like our big nail. So I'm actually going to put those two together because they were the ones that the primary material underneath it all is a good conductor, but when they get dirty, they don't work so well. All right, our screwdriver is our last thing here. We're going to save this one for our other tester. Our screwdriver here, I'm going to put one on this end and one on this end, and it does not work. Does not work because even though this is metal, this end is plastic. Plastic is a conductor, or an insulator. Plastic is an insulator even though the metal is a conductor. So if we take and we put both of them on the metal part of our screwdriver, it works. Okay, but if we put one on the plastic part, the plastic becomes an insulator. All right, so this one's kind of both. So we're just set it right, like here, I'll set it like this. This end is the conductor and this end is the insulator. All right, so in our notes we talked about solids, and that's what we've dealt with so far. All of these things are solids. They're all solid materials. And if you remember in our notes, metals, and these are all metals, are the best conductors. So that was one thing in our notes. Then we talked about liquids in our notes. So let's see if we can't test some liquids. Now, I have to use a different tester because this 1.5, this 3 volts, wasn't quite enough energy in order for our experiment to work. So I'm going to set this one back, and at this point, if you have a tester yourself, you may just want to watch. I'm switching from 3 volts that we were using earlier to one of these batteries, and it's a 9 volt. You see right there it says 9V, that's a 9 volt, okay? And instead of a light bulb on it, I have a buzzer. I'm going to move my... so if you listen, you'll hear my buzzer go. Okay, so if we hear the buzzer, then we know that it is an insulate, that it is a conductor. Okay, so the first thing we're going to test, I actually have these shiny little brass nails that we tested. That's what I taped them on the end of one of my little hooks there. I taped it with my electrical tape. Okay, so I have that taped up, so it is ready to go. I have these nice little metal alligator clips that I'm clipping it to the 2 terminals on the top of the 9 volt battery. So I'm going to take these little nails and I'm going to poke it into my lemon to see if a lemon is a conductor or an insulator. So if we hear the buzzer, then we know it's a conductor. If we do not, then it is not a conductor, it's an insulator. So here we go, poke that one in, and this one is not a conductor. I kind of thought it might be when I got it out of the fridge, but sometimes you may have seen an experiment that works with lemons or with potatoes, and that works a little different. It's actually generating electricity instead of conducting it, so just a whole different process there. But our lemon itself is not a conductor. Okay. All right, so we're going to move on to the next section that was in our notes, the section of liquids, okay? And I have a few things here. I have a glass of water. I have vinegar. Both of those are liquids. So we're going to start with the glass of water, okay? If you've ever heard, maybe you've been told you have to get out of the pool because there's lightning. So let's see, is water going to conduct electricity? Okay. We ready? Now we're listening for our buzzer. It doesn't seem to be. Well, let's set that aside. Maybe the vinegar will be a conductor. So we'll take a little bit of vinegar, we'll put it in our bowl here. Kind of stinks. And we're going to take our 2 nails and stick them in. In our notes it said that vinegar did work. I'm not sure. What are we going to have to do with this water and this vinegar? Here I have some iodized salt. I'm going to put a little bit in this container, this little bowl here. Let's see if the salt is kind of dry off my nails there a little bit. Is the salt a conductor or an insulator? It does not seem to be a conductor either. What could we do with these to do another experiment? Why don't we put a little salt in our water? Kind of like really sweaty kids getting into a swimming pool. And we'll put a little salt in our vinegar here too. Why not? The salt didn't work by itself. The water didn't work by itself. The vinegar didn't work by itself. If we make solutions here, will that work? I'm not sure. Let's use our spoon here to just mix it up a little bit. Dissolve some of that solid. Dissolve some of that iodized salt. I'm going to dry it off here. Stir our vinegar a little bit. And let's test our salt water. Our pool with a bunch of sweaty kids water. Would you look at that? So, if you need to get out of the pool, it's probably, if it's lightning, you do need to get out of the pool. Probably a definite good idea. Let's take a look. Do you think the vinegar will work with a little bit of salt in it? Yes, it does. So, when we figure out why this happened, it's because there's a certain amount of ions already in the vinegar and already in the water. And when we add iodized salt, iodized means that there's some iron, okay, in the salt. And when we add that to our water, then the solids, okay, in our liquids become greater. And that makes it easier for the electricity to conduct through the water. So if you want to try this at home, you'll need a 9-volt battery. And you cannot use your little light bulbs with the 9-volt battery. Okay, you may have to find a buzzer or a motor or something like that. The 9-volt battery blows your light bulbs right away, burns them out. So they'll just go, whew, they'll light up and burn out. But yes, so liquids do conduct electricity. Okay. The next thing on our list was gases, noble gases. And I do not have an experiment for noble gases, but the next time that you drive past a restaurant or maybe through a busy downtown, if you look at the business windows, you will most likely see one of those bright signs that are sort of made of tubes. And those tubes have neon gas in them, and those are neon lights. And those are an example of using neon gas to conduct electricity. So we don't have an experiment for that today, but I'm sure that when you drive past some businesses here in the next few days, you'll be able to see an example of neon gas conducting electricity. So that concludes our experiment for today. Your homework is to pick 5 things around your house, okay? And you can build one of these testers, okay, if you have them, if you have all the materials. I want you to build one of these testers and go ahead and test the 5 items around your house. If you do not have these materials, then I just want you to mark whether or not you think they're a conductor or an insulator. And from everything we did today, you can probably get a pretty good guess. So your homework is that chart. To fill that out, that's one of your homework assignments this week. If you have any other questions, be sure to send me a message and I'll get that answered. Have a great week and enjoy testing some things around your house.